Okay, so today we have a very interesting presentation. Well, for me, it was extremely interesting. And I'll be talking about generative AI, ChatGPT, and other LLMs, which is large language models. And I mean, there is a huge growth of interest to the subject. And I want to say some key consideration that human intelligence is based on language. Before, we had a lot of models which tried to present data in some low-dimensional or like convenient format, not through language. But now we have this revolution, and suddenly we have models which behave very similar to human brain. I mean, it's really a revolution. This is the growth of interest. So this is without ChatGPT on the bottom, starting from 2004. And you see how different models, which is deep learning, machine learning, data science, OpenAI, how they grow here. And here we add ChatGPT. You see this? This is ChatGPT, and this below is everything else. So, and this is, by the way, interest, which is number of searches on search engines. So some terminology. Well, you're familiar with chatbots, chat software, which runs it. GPT stands for Generative Pre-trained Transformer. And this is technology which was like the key for all these models for the last several years. LLM, Large Language Model, text-to-text. So ChatGPT was developed at OpenAI, and it's taking world by storm. People find more creative uses for it, which we'll look at later. So writing posts, articles, books, summaries, planning, research, software engineering, resolving problems, support, sales, and so on. One thing, so classical machine learning, which we were using for years, concentrates on predicting, whereas generative AI on creating stuff. So in classical machine learning, we can use regression. So we draw the line to predict next points. Or we use classification to say, well, people who bought this also may be interested in this product. So, and so on. But generative AI, it just creates. It may create text, code, images, and so on. And we will look at this. So there are multiple generative AI models, different purposes. LLM, large language model again, and FM, foundation model. So about foundation models. Instead of simple task-specific models of regular classical machine learning, now we're talking about a model which includes language in the middle. So, and we're replacing task-specific models with so-called foundation models. Like it's the same as happened with, for example, Google Translate. Before deep learning translation models, they were models constructed by people. So they were if-else clause, if this word goes after this or whatever. And they were written by linguists and tested, and they were really, really big, like, I don't know, 500,000 lines of code. But then people switched to deep learning, and suddenly you have a model which is 50 lines of code or 100 lines of code. And all the knowledge is actually in the deep learning network, and it learns it by itself. Well, it's kind of black box from outside, but it works better than engineered by humans, right? So now we're applying the same approach to all kind of models. It may be text to text, it may be text to embedding, it may be multimodal. So here examples. Embedding. Here I put definition of what embedding means. So it's a way of representing complex data in a low dimensional space that is more suitable for processing. So typically people use vectors, but it may be something else as well. So here are some models, GPT 3 and 4, ChatGPT, Codex to write code, and DALI 2 to create images. So you give it a prompt, like here, for example, a prompt, and you get the response. So here for code, you give a prompt, and it gives you a select statement. And here you give a prompt to create image, and it creates image. So generative artificial intelligence, large language models. Well, when people talk about generative AI, there are other types of generative AI which don't include language. In this presentation, we will be only talking about the ones with language. And there are multiple models and multiple companies working on it and providing pre-trained models. Well, I already spoke about GPT. BERT. Llama is a model from Facebook. M actually stands for Meta. Commonly utilized vector similarity search to retrieve information. So as I told, you can use model to create embeddings like vector representation of something, and then you can search similarities using vector similarity search, which is simply cosine multiplication of vectors. We'll talk about it. One more thought, that what happening in the last 10 years, models go from computers to the cloud. So here's the example of IBM Watson in 2011. It was running on IBM mainframe computer, and it won Jeopardy show on television in 2011. But now it is like a dinosaur, because now all the models, all the big models we'll be talking about, they're all on the cloud. It's OpenAI, it's Azure, Microsoft, Amazon, Google Cloud. They all have a similar set of foundation models, and they live in the cloud. So I'm just returning here. So again, foundation models. They're generic and trained on broad set of unlabeled data, and they can be foundation for many applications of AI model. So we'll see that. Okay. Next, about the sizes of these models. Well, GPT-3 grew to 175 parameters. Here is the table, and this is number of parameters. So 175 billion parameters in this network. So it's really, really huge. It's not the largest one. The largest is this Megatron Turing machine modeled by NVIDIA and Microsoft. It was created a couple of years ago, and it has 530 billion parameters. Facebook model has 65 billion parameters, and there are other models as well which are big. But ChatGPT made a revolution because they made it available and convenient, and it's quite amazing set of useful features, right? Now, talking about machine learning, model is usually a concise, like compressed representation of data. So for example, if you have 1,000 points, you draw the line through them, and now you have two parameters, slope and intercept, which contain, well, information, like this is the model basically. So you compressed 1,000 to 2, right? So here, for example, with ChatGPT, it was trained on 45 terabytes of data. Well, you can estimate kind of the compression, because you go here, ChatGPT-3, released 2.5 years ago, the largest non-sparse, has 175 billion parameters and needed 700 gigabytes of memory just to store the parameters. But think about it. So you had 45 terabytes of data on which it was trained, and this data was basically condensed into 700 gigabytes, which is approximately what? 1/50th? Or approximately, let's say, no, it's terabytes. Yeah, so it's about 50 times compression level. But it's more than that, because now you don't have just raw data. It understands, and it can summarize it, and it can do so many useful things with it. Now, OpenAI is an interesting beast, because it started as open source, but now they created commercial products. They work very closely with Microsoft and NVIDIA. And NVIDIA created those supercomputers. You see Jensen Huang, who is the CEO of NVIDIA, he is like signing on this computer when it passed to OpenAI people. So these are top people in OpenAI. Maybe you can recognize their names. So this is NVIDIA DGX. Inside it has 8 blocks. Each one is a very powerful GPU. So here are some parameters. Okay, let's go to the very beginnings of generative models. And there is one person, Jan Goodfellow. So in 2014 was his thesis, followed by a publication with 4 authors, which is called Generative Adversarial Nets. And that's where the term GANs was born. Generative model consists of two networks. And I want to give, like, for children explanation how it works. So it consists of two networks. One is like police detective to recognize images and classify them, and another is artistic criminal, which is creative, and it generates fake images and give it to police detective, who is trying to learn and become better at recognizing. And as police detective becomes better, artistic criminal also becomes better, and they end up creating very, very good images, and detective becomes very good at recognizing them. So they're helping each other to become better at their job, right? So this is a link to his thesis, to the article, and this website, Unreal Person. You can go there and you can click, and you can see many high-resolution photographs of people. And it's very difficult to believe that these photographs are actually generated artificially and this person doesn't exist. But that's the quality to which this technology grew over the years. But note, there is no language here. It's all image-based. That's what he was working with. Now, before GANs, again, GAN is generative adversarial networks, there were many approaches which also involved generating something. Well, of course, they were not as interesting as GANs themselves. They were naive Bayes classifiers, hidden Markov models. Like, here is an example of Markov chain Monte Carlo prediction. And the way it works, you do a random walk to see, for example, what will be the price of something. And then you repeat it multiple times, you build a distribution, and from that you will see if the price will go up or not. Well, in this case, it looks like it's more probable to go up. So people use this kind of models in investments, for example. Gaussian mixture models, again, okay, I'll go fast. Restricted Boltzmann machines, deep belief networks, which is like 18 years ago. Variational autoencoder. This is a really interesting system because here, as we go through the network, in the middle, we put Gaussian distribution, and there is two nodes, one representing the mean value of the distribution and another it's sigma. And these values are used to generate the value randomly, and then it goes back and forth. So very interesting approach. So it allows to generate new data by sampling from the learned distribution. Okay, but for me, like, real beginning of generative models is with Jan Goodfellow. That's where really interesting stuff started to happen. Okay, Google Translate. Google Translate 2016, and in this article with many authors, 31 author, they introduced attention mechanism, which basically is a foundation of transformer, which is foundation of all large language models. Next year, they published an article, Attention is All You Need. So this is this article, you can read it. It has 8 authors, and it's, again, it's basically a transformer. So let me give some simple explanations. Before, there was something called word-to-vec. And word-to-vec model is a model where you take words and you look at words around them, and you try to represent the words as vectors based on the words neighbors, just words before and words after. And it's an iterative process which generates those vectors. The good thing about this process is that similar words, similar in meaning, even if they are spelled completely differently, but in this vector space, they will be close to each other. And you can do vector operations like vector of king minus vector of man plus vector of woman. You get a vector which will be very close to vector of queen. So this is good, but this is very simplistic, and it only looks at the closest words. Whereas with the attention mechanism, it can go on a position, and positions can be far from the word you consider. And I mean, it's really interesting approach. It has some analogies to fast Fourier transform and some other. So mathematically, it's very interesting. And so it's called attention mechanism. Transformers. So again, 2017, attention mechanism and transformers. So it's a classical architecture. It was made better and better and faster and more effective and more tuned over the years. But this is what everybody is using now. Like all these large language models, that's what they use. And BERT is bidirectional encoder representations from transformers. So it is a big model, and it can be pre-trained and provided in like pre-trained state, which means that now you can use it and change it a little bit with small amount of training, which make it very, very well practical. And oh, the word BERT also is a Sesame Street character. Okay. So what is a transformer model? I absolutely will not go into it. We had a separate seminar. This is the slide from this seminar, and here are some logs, I mean some articles and YouTube videos, which I recommend you can explore. So we moved from recurrent neural networks to transformers, to pre-trained bidirectional models, and finally to GPT. So generative pre-trained transformer, GPT. Okay, and here it talks about how number of parameters was growing. Hugging Place is a very famous website where people go to get the models. And on one of our previous seminars, Boris was talking about search engine for images, and he was using model. So he was taking it from and retraining it a little bit from Hugging Face. Foundational models, BERT, GPT-3, CLIP, Codex, and so on, OpenAI, parameters. This is kind of repetitive because I already spoke about it. This is some terminology: convolutional neural network, recurrent neural network, and so on and so on. And here we have BERT and GPT-3, reinforcement learning. I'm not covering it today. Anyway, ChatGPT history not related to generative AI. Well, in 1950, Alan Turing proposed a criterion of intelligence, which is called Turing test. And the idea is that we have a written real-time conversation with a human, and then the human unable to tell if he communicated with a human or a machine, right? So it's kind of like a chat program, and we're close to it, right? ChatGPT is very intelligent. We're getting there. Elisa, this is just a toy. It's a chat program simulating psychologists, psychiatrists. So it would recognize some keywords like mother and then tell you, like, tell me about your family or your mother or something. And there are some other chatbots, but this was very primitive. Okay, today we have many chatbot services which are not necessarily AI driven. Like, for example, for many years, Amazon was using for their own customer service, they were using something called Lex. And it's available as a service. So they first created it for themselves, but then they started also to provide it for external clients for, well, for money, for subscription. Google Dialogflow, similar thing. You can create structured dialogues in your, let's say, customer service chat. Of course, nowadays, all these human-created programs more and more being substituted by programs where they use something like LLM in the middle. So instead of human written, you use just AI, artificial intelligence. Well, Google Bard, this is a new thing. I tried Bard. I didn't like it as much as ChatGPT. And Azure bot services, and there are some other bot services. Okay, so recent developments. Okay, Google Bard, collaborative partner. Okay, it's Google. Microsoft issued new Bing. Well, Microsoft is very closely associated with ChatGPT, with OpenAI, and they provide all the services, OpenAI services, inside Azure cloud as paid services for their clients. But Bing, somehow I didn't like it. I didn't find it as useful as ChatGPT. Microsoft 365 Copilot, GitHub Copilot, NVIDIA has its own models. Okay, so how close we are to artificial general intelligence? So what is general intelligence? One definition was Turing test, where we're talking with a chat program. Another definition, like there are multiple definitions. Like, for example, if we'll have a robot which can go into the kitchen and make a cup of coffee, or a robot which can take a box with furniture from IKEA and assemble it following the instruction. I don't know how close we are. Maybe a few years. Ray Kurzweil was estimating that we will have artificial general intelligence by 2030. Well, if he is right, and he is usually very close, then we just maybe 5, 6, 7 years, and we will have AGI. So we have data, so it's path to artificial general intelligence. We have data, we have information, we have knowledge, structured, we have intelligence and wisdom, which is AGI. So we're somewhere in the middle, right? But we're moving very fast. Okay, here is example of how ChatGPT works. And you see, it's absolutely not perfect. So I asked it a simple question. If 1.5 hens lay 1.5 eggs in 1.5 days, how many eggs will 3 hens lay in 3 days? And the answer is 6. So you multiply this by 2 and this by 2. Oh no, this by 2, so by 4. So 1.5 times 4 is 6. This is the correct answer. But both ChatGPT 3.5 and ChatGPT 4 gave wrong answers. And this is the explanations. What's interesting is that if I received the wrong answer, then I said, well, I changed the problem. If 2 hens lay 2 eggs in 2 days, then it gives correct answer. And then I repeat the first original problem, and now it gives the correct answer. So it can learn from context, from history. Very interesting. So what AI ChatGPT can do today? Well, it knows a lot of facts. It can answer questions, explain terms, concept. It's a good encyclopedia and very good tutor. I like to ask ChatGPT more than go to documentation. It's really like it helps me understand what to do and gives examples, useful examples. But I cannot trust it. It's not always correct. It may be correct 80% of the time, but I quote it making like terrible errors. ChatGPT usually gives you the most common answer, which may be wrong, because, well, the crowd may be wrong, right? There may be only one person in the crowd who is right, but ChatGPT will give you the quote crowd answer. So you have to be careful. ChatGPT may give you biased or politicized answers. Yes, that's true. ChatGPT helps with doing simple technical tasks, including software, writing, planning, research, graphics, formatting. Lawyers can ask it about existing laws on the subject. Software engineer can ask to recommend tool or libraries to solve specific problems. ChatGPT can easily confuse trying to solve real-life problem. It is still not a good substitute for a human, that's for sure. Okay, here are some examples of generating images. So we have OpenAI, DALL-E, and DALL-E 2, and these are links. Midjourney, Stable Diffusion Model, GigaGAN. I mean, really interesting, 1 billion parameter model, and its main feature, it's extremely fast, and it can give you a good size image in split second. Quite amazing. So are there dangers of AI? Like, is Terminator is possible? Well, in March, a whole bunch of very famous people wrote an article, and on the next slide, I provide the text, not an article, like open letter. So they're warning about potential dangers, and they want to slow down. Some people don't agree. They say, no, we should continue to move forward. We can maybe regulate the products, but we should not regulate or stop the research. and especially Jan LeCun and Andrew Ng. This is the YouTube video in April. We're discussing this subject. Okay, some examples of using ChatGPT big models. Well, the first one, of course, is writing. So you can write plans, outlines, summaries, legal contracts, list of topics, posts, articles, books, whatever. Great feature of ChatGPT that it can write text and then you can direct it to improve it over and over again. So it's like a multi-step approach. A very good useful trick is to include a request for ChatGPT to generate a hierarchical table of contents before providing the answer. So this is really good. It causes AI to carefully analyze the structure of the issue at hand, organize the thoughts in a logical manner, much like a human writer would create an outline to plan and organize ideas before actually writing the book, essay, or speech. For example, you want to write a book, you ask ChatGPT to give titles, let's say 10 titles, you select the one you like. Then you ask ChatGPT to give 10 chapters, the main topics of the book. Then for each of those topics, you ask for, let's say, 10 subtopics. And then after a little bit going back and forth with ChatGPT, you then ask to write each subtopic. And here you have a book. You can ask ChatGPT to write for different ages using a language of different complexity, write in different languages if you want. It can translate for you. In style of known authors, it can write poems, whatever. Software. Okay, well, I use ChatGPT to write text, but I also use it to write software. I find it very, very useful. One thing, and this is not me, but somebody's quote, if you don't learn these tools like ChatGPT, you will not be able to compete with other developers. Using ChatGPT makes you much more effective. Fastest growing programming language in 2023 is English. It is actually human language. Prompt engineering. There are now multiple courses teaching you how effectively work with ChatGPT. So there are some best practices on OpenAI website. Also, there are courses from Andrew Ng and some others. Using ChatGPT as a data engineer. So this is a Medium article, and the author talks about building boilerplate code, add comments to your code, debug basic errors in your script, convert code from one language to another, creating flowcharts and of the process or code. And by the way, about creating flowcharts, you can ask ChatGPT to export it in a mind map format, like a JSON format, which then you can use software which will show you as a graphical representation, like a mind map, like a diagram of your logic. Okay, how I save over 5 hours every week using ChatGPT as a data scientist. Again, this is an article, and this is what this person was doing. Visualizations, conversion to other languages from Python, code summarization, optimization of code, generate README file, creating regex expressions, refactor code, make it better, code comments. Well, comments, okay, yeah. Next, AutoGPT. Again, this is an article which I really liked, and the person was talking about automating something using GPT in the middle. So AutoGPT can act as an intelligent intern, which works for you, can browse the web, discover next upcoming events, give you original recipes, can do AI-powered research, build a website, can automate your work in Discord with AI agents, can automate your podcast creation, and so on. Yet another article which I really liked, use ChatGPT as your private teacher. I do it all the time. Ask ChatGPT for advice about your life, health, menu, exercise program, like how to improve something, how to tune your life. Actually, this is a good advice. Why not ask important life questions? Scan and describe images with ChatGPT. This not widely known, but you can put image online and then take the URL to this image and just paste it to ChatGPT and then ask it to describe it. So you cannot copy paste the image itself, but you can copy paste the URL to the image, and then ChatGPT will be able to actually look at it and describe it and discuss it with you. You can summarize articles, papers, and posts. You can provide text, or again, you can provide just a URL link to the text, and ChatGPT will, well, read it and discuss it, or summarize it, or whatever you need. Of course, there is Python API. Everybody nowadays using Python. There are a lot of links and toolboxes. One of the famous toolboxes is a company called LangChain. So it's an open source toolbox LangChain is a software development framework designed to simplify the creation of applications using large language models. So here you have Wikipedia, GitHub, their website, and documentation. It was released less than a year ago. It was created by Harrison Chase, and it's written in Python and JavaScript. It's amazing. And if you go on YouTube, you will see a lot of videos, tutorials, how to start, how to use it. So definitely way to go. Oh, by the way, I really like the logo because ChatGPT is like a parrot, right? So, and it's a chain. So you have on some of the pictures, you will see two parrots trying to talk to each other, whatever. So language chain. Models, including language in the middle. Chat PDF, again, very powerful. I have a friend, she's a scientist, and she is using this to read the paper and then summarize it and discuss it with you. So scientific paper, it's a PDF. She gives it to this ChatGPT thingy. Okay, a little bit more. So I listened to a very interesting Redis presentation. Redis, for those who don't know it, it's a very good database. I used it on several projects. And it's not SQL database. It's a database which keeps lists, queues, like a hash map type of thing, like dictionary. It is in-memory database. It's very fast. It's very clever. And what Redis developers did, they created a new approach where they hold vectors, and then they can do a comparison of these vectors. They can do search based on how close these vectors are to each other. Here are some examples. This is similar when I was talking about embeddings for words. Remember king, queen, man, women. So this is a kind of similar approach with the vectors, with the embeddings, and they make the database the vector database. And then they can do comparisons. So let me show you. Here is an example. So you have a store which is selling clothing, and you select a piece of clothing, let's say it's a sneaker, and then you can ask, search for similar products. So each piece of clothing may be described by a vector. So it's embedding, it's a vector of features, like is it a shirt or a sneaker? Is it for man or woman? Is it adult or child? Is it this? So you have many, many parameters which constitute the vector. And then you can, this database allows you to find similar vectors. You see? It's quite impressive. At Google, of course, we have the same foundation models, text, code, image, chat, dialogue, audio, music, embeddings, which then you can use for other things. And this is Azure OpenAI. And again, you have same things. You have content, summarization, code generation, semantic search. Well, this is just for text, but they all, of course, have for images and other stuff as well. Last slide. Automated money machines. I wanted to write about how to make money with ChatGPT, but you know what? If you just go on YouTube and you search for this, you will find so many videos how I made so many thousands of dollars last month using ChatGPT. It's like just absolutely endless. You can create and sell products like books, reviews, summaries, music, plans, contracts, so on. You can find and recommend and sell bestsellers. You can save money on consulting and software, and so on, so on. Okay, this is the end of presentation. I was rushing because there are a lot of slides, 43, but I think we're good on time. That's it. I guess I'll stop recording.